We started Avagon a little more than a year ago with an idea. The idea was to create a product that's audio when you want it, it fits where you already have room for your headphones, it adds visual, and you can just plug it in and push a button.
Here at Avagon, we've created the Avagon Glyph. It's this amazing convergence audio-video device that contains our core technology, which is what's called a virtual retinal display. What a virtual retinal display is a display with no screen. We use a series of micromirrors and patented optics to try to create this really vivid, natural, comfortable light so that when you see images inside the Glyph, it seems so much more realistic and sharp and brilliant, unlike any image you've ever seen before.
Where we initially thought this would apply to the military market, we realized that consumers who watch movies have the exact same requirements. Into anything that you can hook a screen up to, our device can quickly plug into and interface with. We're using micro mirror arrays for a variety of reasons. It has a really high fill factor, and what that does is it creates a solid image rather than a pixelated image where you can see a screen door effect. This is really important for image quality. The speed of the image that you see is very quick, and this is important for any sort of augmented application or virtual reality application where there are inputs like head tracking.
Whether you're sitting on an airplane, waiting for a bus, or just simply hanging out at home, all you need to do is flip down the visor and suddenly you're immersed in this whole new world. We want to make sure that this is an amazing experience for everything you own today, everything you want to buy today. But we also look at developers. We think that developers are extremely creative and they're going to come up with brand new ways to use the Glyph in ways that we can't even imagine.
When we started Second Life, the way that you had to get into the virtual world was using a mouse and a keyboard and a screen. There's so much happening right now around this idea of how the more head-mounted display can be made to work well. The first time I saw the Avagon prototype, I was really intrigued. The brightness and the fact that I really couldn't see the visible pixels in front of myself, I thought were very positive aspects of this display, in addition to the fact that we're going to have the option here to integrate a gyro and head movement motion into what you see on the screen.
The best way to sell anyone on a technology device is a compelling demo, and the first time I saw the Glyph, it was beyond compelling. The high-quality audio and video in such a small form factor is amazingly innovative and game-changing.
The thing that really excites me about this job is to be part of a team that is reinventing the future. It's not about just building a better product. It's actually building a platform nobody's ever seen before.
We are on a mission to unlock the essence of reality in virtual worlds, to enable human integration with technology that is so seamless, all it takes is a glance for your digital environment to react at the speed of thought. We are Fove, the world's first eye-tracking virtual reality headset.
Fove is pushing the boundaries of what is possible with virtual reality and helping to realize its true potential. We wanted to create the next generation of VR, so we developed the world's most advanced eye-tracking technology and are complementing it with a high-resolution screen and low-latency tracking.
As the user perceives the digital environment, Fove's infrared cameras track their pupils and register the slightest movements. With each expression, glance, and blink, the user's intentions manifest in the virtual world.
Because Fove knows exactly where the user is looking with imperceptible delay, we can enable a technique called foveated rendering. This allows us to focus the fidelity in the part of the vision that matters most, leading to better performance on lower-end hardware than is currently possible.
By calculating subtle parallax between pupils, Fove enables software to present virtual environments with realistic depth of field, improving immersion and allowing the eyes to relax when viewing objects at varying depths. And by enabling fine control with the eyes, Fove significantly reduces simulation sickness through the elimination of unnecessary movements. With Fove, artificial intelligence becomes more responsive and nuanced, reacting to the player's most subtle intentions and providing more realistic interaction. With eye tracking, we can create a truly natural user interface that is intuitive and nearly subconscious in action.
What is truly interesting with eye tracking technology is that it enables users to deeply interact with the virtual reality world by translating subtle eye movements into emotional expressions which can be read and reacted to just like in real life.
But that's just the beginning. Fove technology enables entirely new forms of expression, communication, and movement. Those with restricted use of their hands can simulate a mouse and keyboard using only their eyes. Users can even control a robot to look around the room and give others instruction with just his eyes. Fove has a profound future. Our technology will not only react to and emulate complex human emotions conveyed through the eyes, but also through facial expressions. At last, with Fove, we can fully integrate human expressions into everyday VR.
Fove is not just a dream. The technology is already working. Our team has been demoing the Fove prototype around the world, and the power of our technology is clear. People everywhere are really excited about this.
Fove's amazing. We at High Fidelity are working on letting people interact as avatars while they're in head-mounted displays. This is a solid HMD, even without the eye tracking. I'm really excited to see that combined with eye tracking and see what we can do with it. This is a huge step forward.
It's an incredibly complex technological problem to track eyes in real time and have it interact in the environment. There is a company who has solved this problem, and that's Fove, and we're very excited for their product to come to market.
Eye tracking really works very, very well. I support these guys 100%. Let's go Fove.
As a game designer, working with the Vive is crazily fun. It's like amazingly blockbuster fun.
Room scale actually brings about a significant range of freedom for the designer and the developer.
When they finally showed us the Vive, it was honestly like a dream come true.
The opportunity to work with something that has that kind of fidelity, something that we can rely on as a developer, it's such a reward.
It's just allowed us to explore all of these new mechanics and ways of doing things in the game.
Final Approach is an airport management game. The goal is for the player to manage airport traffic, taking airplanes off, landing airplanes, refueling, handling emergencies.
We're currently working on episode 1, Call of the Starseed, the story-based game, and it's all about just being in a whole new world and interacting with cool characters.
Fantastic Contraption is a game all about building stuff. You are the player at the start of the show. It's all about your creativity. Move around and do stuff and build machines that roll around and that walk around and that move from place to place.
Job Simulator is basically in a future in 2050, the robots have taken all of our jobs. The robots were kind enough to put together this job simulator so that humans could remember what it was like to job.
It's such a dramatic difference and a contrast between the way we've always done it from the beginning of time until now.
We're learning a whole new language to move around this world, what the affordances are of this world, how people communicate.
Complete paradigm shift in how you design games.
Oftentimes a lot of the traditional game mechanics don't translate well into room scale VR, so it requires a whole new mindset.
You're thinking about how it is to move around and use motion controls in the real world and having to take that into your design. We're finding that you have no concept of what will work and what won't work before you try it.
For us, that's what's most exciting about the Vive, is that it gives us that creative opportunity to break the rules and make new rules.
I think there's a big problem with the perception of what VR should be or could be or was when it died in the 80s and people saw its rise and fall when the technology just wasn't quite there. And the Vive has totally changed that for a lot of people, but you have to put it on and experience it to see that.
This is not really a virtual reality, it's an alternate reality. People can go into that space and they can be human in that space.
We certainly think it will change the future of gaming. You can't really go back and look at games the same way you did before.
Once you get your hands on the Vive and you really can try it and wrap your head around it, you can really understand all the different potential applications from business to communications.
The medical and simulation and training and military and
opportunities to send humans virtually into unsafe spaces.
It puts you in an immersive environment and lets you take control of the whole world.
Samsung has made the exciting world of virtual reality a reality with Gear VR Innovator Edition. Powered by Oculus and the Galaxy Note 4, Gear VR is a virtual reality headset that lets you experience games, movies, and more like never before. You simply insert the Galaxy Note 4 into place and put it on. Then select Milk VR and get ready to be amazed. You're gonna want some serious sound.
Whoa.
What a view.
Gear VR plunges you into a totally immersive 360 environment. What do you think?
Feels like I'm really there.
You can see things from a whole new perspective. Ready for another adventure? Navigate menus, explore worlds, and play games by simply turning your head, swiping, and tapping the side-mounted touchpad.
And now I'm on a safari.
Gear VR brings the experience to life. And where are you? I'm in a really intense battle. Take that. Whoa. Looks like the best seat in the house. Up, down, side to side, even behind you. Everywhere you look, you're in the action. Wow. And it all happens on the Super AMOLED screen on the Galaxy Note 4. The world of virtual reality is finally here. With Samsung Gear VR Innovator Edition, powered by Oculus and the Galaxy Note 4.
We've spent the last year working on building Developer Kit 2 as an update to our original development kit, something that gets a lot closer to what we want the consumer version to be, and lets developers make much better virtual reality experiences. DK2 has a variety of different improvements, largely around comfort and presence.
The sense of presence in virtual reality is something fundamentally new. You actually, for the first time, your brain says, okay, I'm comfortable in this environment. I know it's not real, but I think it is. With the second developer kit, a year of R&D, we're getting a lot closer.
DK2 has lower latency, higher frame rate, higher resolution, and low persistence, along with full 6-DoF positional tracking. All of these combined allow for much better gameplay experiences and a much more comfortable user experience.
With DK2, we now have sub-millimeter accurate position tracking, which means that the views can respond the way it actually should in all cases.
That allows you really to lean forward, lean backward in space, lean around corners. It just opens up so many gameplay opportunities and changes fundamentally the way you can develop content.
Another huge improvement that we made is using a low persistence display. Our low persistence display shows an image only for a brief amount of time. Then the display goes dark until the next frame comes in. Doing this at a high enough frame rate means that your brain does not see any motion blur or any judder in the resulting image.
2 years ago, I thought all we needed was faster pixels, get to 120 Hz OLED response time, and we were done. And it was really exciting to see Valve's research, which demonstrated so vividly what a difference the low persistence display makes.
We've also greatly reduced the latency in our system by improving our code, video pipeline, and display. Our original dev kit was 60 frames a second, not because that was what you really need for a great convincing VR experience. It was just the best display that we could get our hands on over a year ago. Now we're using a higher frame rate OLED display that really makes a huge difference.
It's really not that there's just one thing that's better about DK2, it's how all these new features come together to really take the experience to a whole nother level.
We've spent the last years figuring out what consumer virtual reality needs to be. We know what we need to ship. Everyone at Oculus is passionate about building the best virtual reality technology in the world.
One of the big goals at Oculus is to bring together the smartest people in the world. We're working on hardware, software, we have creative, we have infrastructure. The only way we're going to deliver virtual reality, the holy grail, this incredible pursuit of presence, is by recruiting the very, very best in the industry.
I think that's one of the main things that held virtual reality back for years. The right group of people never came together to work on the right problems. I think that's what Oculus has done. We're bringing together the best developers in the world, the best talent in the world, across multiple disciplines to build something that everyone thought couldn't exist.
The virtual reality community is stronger than it's ever been before, and we would not be where we are without them. There are hundreds of virtual reality experiences being created, more content in the last year made for VR than in the last 20 years combined.
It's going to be the small teams that go out and do something that's so fundamentally cool that it winds up defining the language for the platform.
We can't wait to see the experience